Hey there, I'm BogdanBudaca and welcome to my channel. Thank you for joining me for another mind workout. I hope that you're staying indoors and that you keep safe and you keep learning. Today we will go over another cool little problem. We will be using the C programming language, and this one will be a bit more complex, but we will break it down really nice, and I hope it won't take us too long to solve. Of course, whenever you feel that you can continue on your own, please pause the video and do so. So yeah, let's dig right in. What we need to do today is validate a credit card number. How do we do that? We run a checksum on it. What does that mean? We basically run some calculations on the digits of the credit card number, and if a given condition checks out, then we know that it's valid. Okay? This also employs what's known as Luhn's algorithm. You can look that up online and have a read. It's pretty interesting. So we would also have a few other basic conditions, but we can leave these for the end. We will have three examples: American Express, MasterCard, and Visa. American Express starts with 34 or 37 and it's 15 digits long. MasterCard starts with anything between 51 and 55 and it's 16 digits long. And Visa starts with a 4 and it uses 13 or 16 digit numbers. Okay, there are other cases, of course, but we will just focus on these ones for our problem. And for example, where would you need this? To validate a credit card number, for example, when you're making an online purchase. So this would be, you have a form and you input your credit card number, and if it's invalid, it just says, oh, this number isn't good. Okay, it's like a first line of checks to see if the number you provide is valid. Okay, so how does the checksum work? Basically, there are two cases. So first case and second case. So for the first case, we start with the last number and we add every other number. Okay, so we would have 4 plus and then every other number. So we have a bunch of zeros. We're gonna skip these. So 4, next, and this is a 3 plus, so we were down here at the 3, and next is a 0. Okay, this equals to 7. Okay, so for the second case, it's basically the same thing. The only difference is that we start from the second to last number, we add every other number, and another small difference is that we multiply each digit by 2. Okay, so we start with the 1. It's 1 multiplied by 2 plus, we're gonna skip all these zeros again. So next. We were at the 6, weren't we? So 1, next. Yep, 6. So 6 times 2 plus. So we were down here at the 6. Then it's a 0 plus 0 plus. So where were we? 6, 0, 4. Okay. So 2 times 4. Oh, sorry about that. 2 times 4. Okay, so we have 2 plus 12 plus 0 plus 8. Okay, so one thing here, whenever we have a 2 digits number, so if, for example, if our digit will be 5 or greater than 5, between 5 and 9 basically, if we multiply it by 2, we would get a 2-digit number. Okay, so whenever that happens, we add those 2 digits as well. So here, if we have 12, we will have 3, 1 plus 2. Okay, so we actually have 2 plus 3 plus 0 plus 8 equals to, what do we get? 13. Okay, good. Okay, actually we can do this like 1 plus 2, so it would be clear. Okay, and then we just add 7 and 13, so we get like a final sum. 7 plus 13 equals 20. Okay, and the condition says that this number should end with a 0, or in other words, 20 modulo 10 equals to 0. Okay, what's modulo? Basically, it's, for example, if you do modulo 5 modulo 2, actually need the modulo as well, 5 modulo 2 equals 1. So what does that mean? It's the remainder of the division. Okay, so if we divide 5 by 2, 2 goes into 5 twice, so 2 times 2, that's 4, and 5 minus 4, the remainder is 1. So the quotient is 2 and the remainder is 1. Okay, So if our number ends with 0, modulo 10 would always be 0. Okay? So that's our main check here. So how would we go about doing this? So if we have the number here as an example, how do we get the last number, the last digit? So again, if you're not familiar with modulo, you can look that up online. It's pretty interesting as well. How do we get the last digit? We can use modulo. So this number, I'm just gonna go to the next row actually, so we'd have it there. Modulo 10 gives us 4. Okay? So if we divide this number by 10, we will have a remainder of 4. Okay? So that's how we get the last digit. How do we move 2 digits over? So we need to add every other number. Okay? How do we move 2 digits over? Basically, we can use a division. So this divided by 100 equals to the number, and we just scrap the last 2 digits. Okay? We're going to be using integers, so we won't get like a dot decimal result. We will just get this part here, the integer number. Basically, that's how we would scrap the last 2 digits. So these are the 2 main methods we're going to be using. So this is how we get the last digit. We use modulo 10, and then to move 2 digits over, we divide the number by 100. Okay? So then for the first case, we would need to iterate through the CC number, and then we would need to use modulo to get the last digit. We would have like a sum counter, for example, add last digit to sum, and then divide the CC number by 100. So this would allow us to move 2 digits over, and then repeat. Okay? That's the first case. The second case, what we will need to do, we can actually get this stuff here, treat the CC number. Actually, first we would need to, so if we want to start from the second to last number, we would actually divide the number by 10 off the bat. Okay? So divide the CC number by 10. So we would start with the second to last number. Okay? And then these will be pretty much the same. I'm just going to change the numbers. Iterate through the CC number, use modulo to get the last digit, add last digit to sum, divide the CC number by 10, and repeat. The difference here is that we will multiply it by 2, use modulo to get the last digit, add the last digit multiplied by 2 to the sum. And here we would have 2 smaller cases. So here we will basically check if it's made out of 2 digits. How do we do that? How do we get the last digit? We use modulo. Okay? So to get 2 here, we use modulo 10, and we'll get 2. To get the first digit 1, we will divide it by 10. Okay? Because 12 modulo, so for example, I'm gonna go down here. 12 modulo 10 is gonna be 2. Okay, so that's our last digit, and 12 divided by 10, we're using integers, we will get 1 point something, so we'll just get the 1. Okay, and then we can just add these up, 1 plus 2. Okay, so use modulo for the last digit, 4.2, use division for the first digit. It will always be the second digit, but I'm just calling it last on 4.1. Okay, and 4.3, sum these up, and that's it. That's pretty much it. That's the idea here. Then we divide the CC number by 100 to move 2 digits over, and then we repeat. Okay, so this is what we need to do to get started. Then we will do some other things as well, of course, but this is what we need so far. So let's start implementing some of this. So let's start here, include standard io.h. So int main void main class here. So having these long numbers, we would actually use, you guessed it, the long data type. Okay, long credit card number. Okay, and now we will request it from the user. So here we have printf, please input cc number. So we will prompt this up. Okay, then we'll use scanf. Here we will have the long, and we would send it to credit card number. Okay, and the condition here would be while. So what do we need to do? We need to make sure that credit card number is greater than 0 or not equal to 0. Okay, so while credit card number is less than or equal to 0. So while credit card number is less than or equal to 0, actually we will keep prompting for the credit card number. Okay, so we have that down. And here, so I propose we use like a working credit card number. Okay, so we would always have this one here untouched. Okay, because we will keep modifying it, so it's better to have like a working one. Okay, this will be long as well. Working cc equals with, and we will initialize it with the credit card number. Okay, so we have this down. So let's start with the first case, while working cc. So we need to make sure we don't go past 0. So while working cc is greater than 0, we will create int last digit equals to working cc modulo 10. Okay, so this is what we said we're going to use to get the last digit. We actually need the sum here, and sum here we will add this up, sum plus last digit. Okie doke, and here we will basically just need to modify working number by dividing it with 100 by 100. Okay, so this should be pretty straightforward. So if we have 1 2 3 4, for example, we will get the first digit, the last digit, that's 4. We have 4, so then we divide it by 100, then we will get 12, and we get 2, and then if we divide 12 by 100, we will get 0, so that's where we stop. So we get 6. Okay, so I hope that makes sense. So for the second case, actually we will need to replenish working cc. So second case, so working cc equals with credit card number, and we will divide it by 10. Okay, so we will start with the second to last number, okay, digit. So here, while working cc is again greater than 0, we will use this stuff again, basically last digit. Then we will actually have another one, and let's say times 2 equals with digit multiplied by 2, and here we actually need to say something like sum equals with sum plus, and then we want to add the two digits, right? For example, if it's, so if we have, for example, 12, if we do modulo 10, we get 2. If we divide it by 10, we get 1, and we add those up. If, for example, we have a single digit like 5, modulo 10 would simply return 5, because 10 10 doesn't go into 5. So whenever that's the case, you just get 5, and dividing it by 10 would be 0, and 0 point something, and then you just get 5 plus 0, so it's the original number. Okay, so here we would have two cases, so times 2 modulo 10 for the last digit. We could do this in any order, of course, and then we can reuse this and say, oh, I don't have the first parenthesis, and just divide it by 10. Okay, so that's how we get the sum of the two digits, if that's the case. If it's one digit, that's okay as well. And then we divide working CC by 100 again to move two digits over. Okay, so I hope that makes sense. And now basically we have the sum. What do we need to do? We need to, so we will check for a condition as well, but one thing is we need to take care of these conditions as well. So how do we get the first and the first or the first two digits of the number? So one way would be to, for example, if we have 1, 2, 3, 4, 1234, how do we get the first digit? We can divide it by 1000. Okay, so that would be 1 point something, so that's the first digit. How do we get the, so divided by 1000 equals 1, and divided by 100 equals to 12. Okay, so if we divide it by, so I propose we get the count, the length of the number. So for example, if it's 4, we will just iterate through that and basically use 10 and multiply it by 10 by a set number of times. Okay, and that's how we get the divisor here. Okay, so if we need the first number for this case, we would basically, for example, if we have an initial number of 10, we'll multiply it by 10 twice and we will get 1000. Okay, how do we get 10 twice? If the length is 4, so length equals 4, divisor equals 10. How do we multiply it by 10 two times? We basically loop, we use I that's less than length minus 2. Okay, so that will be 4 and we will have 2, so we will have 0 and 1, so 2 times. That's how we get 1000. Okay, 10 times 10 times 10. Okay, this will, the divisor being initialized with 10. So I hope that makes sense. And for the 100, basically we can just use whatever we get in the final divisor and basically just divide it by 10. Okay, so we would instead of 1000 we would have 100. Okay, so we can set that up here. But how will we count? How would we count the length of the number of digits? Okay, so for that, what I propose is we loop through it and we divide it by 10. So we have 1, 2, 3, 4. Again, we divide it by 10, we get 1, 2, 3, and counter goes up by 1. Okay, so we have 1 digit. Then we divide it by 10 again, we have 12, and it's 2 digits. Then we divide it by 10, and it's 1, and it's 3 digits. Then we divide it by 10, and then it's 0, and it's 4 digits. Okay, so the condition will be while the number is different than 0. That's how we get the length as well. So let's implement that here. So while we would actually need working CC again, replenished, so to say. So we will send credit card number to it again. So while working CC is not equal to 0, we will, let's create a variable here, and count equals to 0. So here we will get sorry about that. So working CC divided by 10, no, working CC equals to working CC divided by 10, and our count would be incremented. Okay, so this is how we would get the count. We can actually even test that out really quick. So printf, this is an int, and count. Okie doke. So let's spawn a terminal. So here I use the GCC compiler, and we have credit. I'm gonna output it to file name credit. So good, we have no errors. Credit for so oh, something's wrong here. Okay, I'm gonna terminate this. Something is wrong here. I'm gonna try to figure out what. So while working CC is different than 0. Oh. So we divide this by 10, and then we increment count. Then we print count. Maybe I'm just gonna comment these out for a second. I'm not sure if that's the culprit. Something's not right. I wonder what. Printf, scanf, get the credit card number here. Okay. No, I need this one here. Okay, working CC, credit card number. Actually, we wouldn't need this one here for our case. CC, wow. Okay. Count. This should be good. Oh, here we go. Okie doke. So, oh, sorry about that. Okay. Might have been overlapping with something here. Uncomment this. CC, so yeah. Yeah, we modified here, so we need it replenished. I hope we're just not overlapping here or something. Well, let's just go on, and I hope it's going to be fine. So now we have the count. So let's do the first digit equals working CC. Actually, we can use the credit card number because we won't be modifying it. And times, oh, we need the divisor here. So we're going to do the loop that we talked about. So for int equals 0, int I, sorry about that. Okay, int I equals 0, I is less than count, oh, minus 2, I plus plus. Okay, so this might be a long number. So we're going to have another long divisor equals to 0, equals 10, sorry, we start from 10, just as we discussed. So here, divisor times 10. Okay, so for example, this is for the first digit, right? And we would use this here. Int first and second digit. First two digits. That's better. Okay, equals to credit card number divided by divisor divided by 10. Okay, good. So we have the first digit and the first two digits. Okay, so what we need to do now is basically conduct the final checks. Okay, I'm gonna close this up. So here we get our number. Here we create some of the variables that we need. This is the iteration for the first case. This is the iteration for the second case. This is for, what do we get here? The count, the length of the number. Here we get the divisor that we will use here, so we can get the first digit and the first two digits. And here we can start on our final checks. So if sum modulo 10 equals 0, so this is the main condition. Sum modulo 10, what's wrong here? Oh, there's some issue. Must be a modifiable L value. I'm not sure what that is actually. Let's have a look. And sum. Oh, this is weird. Okay. Oh, okay. We didn't initialize it here. Or that wasn't it? Nope, that wasn't it. And sum equals 0. Here we had the last digit. Here we had the last digit multiplied by 2 in our checks. So what's wrong here? Especially must be a modifiable L value. Not sure what this is. I think we're missing something, but what? Okay, sum. So we actually initialize it here with 0. Change it here. We change it here. Sum modulo 10 equals 0. Am I using the incorrect amount of equals? Yeah, that was it. So this is how we verify the condition. I'm sorry about that. Okay. So if this is the case, and then we need to go through the other cases. So first digit equals to, we need two equals. I'm sorry about that. Okay, so let's have the easiest one, should be Visa. So this is first digit equals to 4. And so here we have Visa uses 13 or 16 digit numbers. So count equals to 13 or count equals to 16. Is that right? 13 and 16? Yep. Okay. But this will have to be one big condition. So this will evaluate first, separately, and the one that's valid from this one needs this. So this is OR, so either 13 or 16, and the one from here will need to be valid alongside this one, because here we have AND. Okay, so if the first digit is 4 and, for example, count is 13 or count is 16, then we need a string here for the result, I think. That's char result length 10. Is that enough? How long is MasterCard? MasterCard, MasterCard 10. Hope that's enough. Okay, so here SCP strcpy, change the string result, we would pass the value Visa. Visa. Okay, so here we would replace the result string with Visa. Okay, else if. So the other ones actually need the first two digits, so let's go with American Express 34 or 37. Else if first digit equals to 34, digit equals to 37, this will need to be one big condition, and count equals to, so how many digits for American Express? We have 15. Okay, 15. Then I'm gonna copy this down here, and this will be Amex. Okay. Okay, and for MasterCard, else if oh, here we have first two digits. I'm sorry about that. Okay, first two digits, that's greater than 50, I think, because we start 51, yeah, and less than 56. Okay, 56, 56. Okie doke. So I hope you're following this along, and it's 16 digits, so the count needs to be 16 digits. Okay, okie doke. And now we copy this here, and we just need this line. This will be MasterCard. Okay, good. So actually, I think this needs to be, so it's not or. I think they should be both be valid. Okay, so first two digits must be greater than 50 or less than 56, and less than 56. Okay, yep, okie doke. So else, we don't need the parentheses, we just need the curly brackets. This will be invalid. Okie doke. And for the big check here, else, and again we get invalid, right? If sum modulo 10 isn't equal to 0. Okay, so I think this should be it. So again, here we have the scan, the variables, the first case, the second case, then we get the count, length of the number, then we get divisor. Okay, then we get the first digit and the first two digits, and here we have the final checks. Okay, so I hope this is right. I'm probably going to see errors if we missed anything, and I hope this makes sense. So basically that's what we did. We got the last digit, added that, then we moved two digits over, and so on. For the second case, we just got we started from the second to last digit, moving two digits over, multiplying by 2, checking that if the number that if the resulting number is 2 digits, we sum those up as well. And then we just got other things like the length of the number, the count, the digit count, and then digit count here. And then we simply create the divisor that helps us get the first two digits of the number, and that helps us validate some of the conditions for the first digit or the first two digits. Then we use the count to validate the length of the number, and of course we have the big condition here, and then we output the result. That's pretty much it. So let's have a go here. Printf, and here we have a string, and we use result. Okay, so let's see how this goes. I hope it's okay. No, we need GCC credit, let's see, output credit. Oh, there's an error here. Pull this up a bit. Writing 11 bytes into original size 10 overflow this. Oh, okay. So I think 11 is the number we need here. See, it complains about result when we send it MasterCard. Okay. Gonna do this. Okay. So we're missing something else. Oh, okay. So we need the string.h library as well. Okay. So I'm gonna go ahead and add that up. String.h, so we can use the string copy. Okie doke. So let's have a go now. Okay, so it seems fine now. credit, so let's get our initial number. So here, okay, it says Visa. We have a couple more here, a few more here from PayPal, so let's get American Express, for example. Amex, nice. Let's get American Express, for example. Let's get one that's not in one of our cases. Starts with 6, as you can see. Invalid. Okay. Let's get, we're not using this case with 2. We're using, for example, this one, 5. MasterCard. Let's get a Visa. Let's get a 13 one. This seems shorter, so it might be the 13 version. 13 digits long version. Visa. Example, something like, okay, invalid. Yeah, so I think this is pretty much it. So I'll close this up. Yep. Well, this is it. So I hope this was as fun for you as it was for me. If you found this interesting in any way, please give the video a like and subscribe. And I'm looking forward to your comments in the comment section. And yeah, I'll see you around.